Welcome to AV3-3, area of an annulus, sector, and segment. Your learning target, I can calculate the area of an annulus, sector, and segment. So let's start with the definition of an annulus. An annulus of a circle is a region between two concentric circles. So concentric circles are these circles here. They have the same center. The annulus is this region here. You can think of it kind of like the donut of a circle. The strategy that I'm going to use for this one to find the area is find the area of the big circle, find the area of the small circle, and then subtract. That'll give you the area of the annulus. Let's take a look at an example. Find the area of an annulus with radius 9 centimeters and radius 3 centimeters. So this capital R is indicating the greater circle, the bigger one. So here we have our big circle, and then we have our smaller circle. We can say this is our center, and from here to here we have 9 centimeters, and let's say here to here is 3 centimeters. So what we're going to do again is we're going to find the area of the big circle, and we're going to subtract the area of the small circle, and that's going to give us the area of the annulus. So our formula again is pi r squared. If we're looking at the big, we have pi times 9 squared. Then we'll subtract away the area of the small, again pi r squared because it's a circle, so minus pi times 3 squared. We now need to simplify. 9 squared is 81 pi, minus 3 squared is 9 pi, and we can simplify here because these are like terms. We can do 81 minus 9 to get 72 pi, and that's the area of our annulus. Again, leave it in terms of pi. Now let's look at a sector. A sector of a circle is a region bounded by two radii and an arc. The area of a sector is proportional to the fraction of the area of the circle. So let's just look at this example. This is my sector, and it's kind of like a slice of pizza. We want to figure out what fraction of the pizza we have. We're going to use this to figure out that fraction of our circle. So let's look at example number 2. We need to find the area of a sector with an arc measure of 30 degrees and a radius of 5 centimeters. So let me just show you a picture really quick. If this is our circle, we're just going to imagine, no, this is not exact, but let's just say that this angle was 30 degrees. We want to know what fraction of our whole circle we have. And to find that fraction, you're going to take the angle measure, and we call angle measures theta. So that symbol there is theta. So whatever that angle measure is out of a total 360 degrees that creates the circle, whatever fraction we have, we'd multiply that by our area formula, pi r squared. We're going to use this to find the area of our sector. So in this example, our theta, or our angle measure, is 30 degrees. So 30 degrees of the total 360 times pi, and our radius we know is 5 squared. Now here, you guys, in this problem, we want to go ahead and continue simplifying. We do not want to put this in our calculator yet. We want to use our skills of reducing fractions to help us simplify. So 30 over 360 will reduce. It's the same as 3 over 36, which is the same as 1 out of 12. And then we have pi, and then 5 squared is 25. I can do a little bit of rearranging to make this look nicer. 1/12 times 25 times pi. Now 25 and 12 do not have any common factors, so I can leave this as 25 over 12 pi. We could also write it as a mixed number, so that would be 2 and 1/12 pi. We could make it a decimal, so figure out what 2 and 1/12 is as a decimal. The only thing we cannot do is touch our pi button. All right, let's take a look at example number 3. Find the area of the shaded region. So again, we need to figure out what fraction of our circle we have. We do that by doing theta, or the angle measure, out of 360 times pi r squared, because that's area of a circle. So we know our angle measure is 133 out of 360. We're going to multiply it by pi, and then we're given our radius of 12, and we need to square that. So we have 133 over 360. 12 squared is 144, then times pi. Here we can see that 144 and 360 can at least be divided by 2, so we could start there. So this will be 72, and this will be 180. Looks like we can keep going. So 72 and 180 can both be divided by 4. 72 divided by 4 is 18. 180 divided by 4 is 45. And I can keep going. I could do by 3, which is 6 and 15. I can do another 3, which is 2 and 5. That's as far as I can go. So now I have 2, I have 133, and I have 5. So 133 times 5 is 266. And then we have 5 as our denominator, leaving it in terms of pi. Now let's look at a segment. So a segment of a circle is a region between a chord of a circle and the inscribed arc. So if we look at our picture, this part here is the segment, and you could think of it as, let's say we have our pizza slice, and this would just be like the crust of our pizza. So the way that we're going to find the area of the segment is we're going to take the area of the sector, which we could call like our slice of pizza, and we're going to take away the area of the triangle part of the pizza, and that is going to give us our crust, or the area of the segment. All right, let's look at example 4. So to find the area of the segment, we want to start by finding the area of the sector, and then we're going to subtract away the area of the triangle, and that's going to give us the area of the segment. So for our sector, remember we need our theta, or that angle measure, out of 360, because that's the fraction we're working with, times pi r squared. Remember, this angle is the same as 120. Okay, so we can fill in what we know. We have 120 out of 360 times my pi times the radius of 13 squared. Now let's add on. We're going to subtract away the area of the triangle. Remember, 1/2 base times height. So if we look at this, we're going to look at our triangle. We have 1/2. We need the base, which is 24. And then we need our height, which is 5. So now we're just going to simplify. 120 divided by 360 simplifies to 1/3. 13 squared is 169 times pi minus 1/2 times 24 is 12 times 5. We can keep simplifying. I know that 169 is only divisible by 1 and 13, so 169 over 3 times pi minus 12 times 5, which is 60. The first term has pi, the second term does not have pi, so that means they are not like terms, which means that this is our final answer. All right, let's take a look at another example. We want to find the area of the shaded region, and it looks like the shaded region is part of our annulus. So let's start by finding the area of the annulus, and let's remember that the formula for that is pi big R squared, which would be part of the big circle, minus pi little r squared, or looking at the little circle. Now, we only want a fraction of this annulus, and we can find the fraction that we want if we know the angle measure. We're going to divide that by 360, because that would give us the shaded fraction of the annulus that we want. All right, let's start substituting what we know. So our big radius for the big circle, we're going to use the diameter of that circle, which is 35. So half of that is 17.5. Now we need to find our little radius, and it looks like this part here is 10.5, this part. So we need to take the whole diameter and subtract this away. That would give us what we're left with, which would be the small radius, which is 7 squared. For our theta, that's our angle measure, so we want to figure out what this measure is. Since we know 160, we just need to do 360 minus 160, which would be 200. 200 over 360 is the same as 20 over 36, or 10 out of 18, or 5 out of 9. 17.5 squared, if I put that into my calculator, I get 306 and 25/100ths. And we're going to bring our pi over. Minus 7 squared is 49 pi. Since these two terms both have pi, I can subtract them. And I get 257 and 25/100ths pi. Still have our 5/9 on the outside. Now I am going to go ahead and put this into a calculator. We're going to multiply 5 times 257 and 25/100ths and then divide it by 9. And we get 142.916, and the 6 repeats, times pi. All right, in example 6, again, I need to find the shaded region, which is a portion of the annulus. So again, we're going to start solving it the same way by finding the area of the annulus, which is pi big R squared minus pi little r squared. And then since I only want part of it, I'm going to use my angle, or my theta, out of 360 to figure out what fraction of it I want to keep. I am not keeping this 30 degrees, which means I am keeping 360 minus 30, or 330 degrees out of the 360. If we look here, we are given the small radius of 4. I'll bring everything else down. Our big radius is 6. Bring everything else down. We can simplify 330 out of 360 because it's the same as 33 over 36, which reduces to 11 over 12. I can do 6 squared, which is 36 pi, minus 4 squared, which is 16 pi. 36 minus 16 is 20 pi. We still have our 11 over 12. I can simplify 20 and 12. We can divide by 2 to get 10 and to get 6. And I can divide again by 2. 10 divided by 2 is 5. 6 divided by 2 is 3. And then I can do some multiplying. So 5 times 11 is 55 over 3 times pi. I could plug this into my calculator to get a decimal, or I could write it as a mixed number, but I'm just going to leave it as this improper fraction in terms of pi. Remember, do not press your pi key. All right, last example, example 7. Find the area of the shaded region. We've got a pretty funky shape going on here. We can start by looking, we have this semicircle here. So we can start by finding the area of that big semicircle. Okay, then I see here that I have these two little semicircles that are the same, and I'm going to subtract those away because I don't want, there's nothing shaded there, so minus 2 of the little semicircles. But then I also see down here, I want to add in one of those semicircles. So we're going to add one little semicircle. So really, I could look at this and say that I'm taking my big semicircle and I'm going to just subtract away just one of those little semicircles, because 2 minus, or negative 2 plus 1 gives me 1. If we're going to take away 2 and then add 1 back in, that's just taking 1 away. All right, so we're going to use pi r squared for both, as that's the area. And we want, since that's area of a circle, we want 1/2 in front of it because we're just with a semicircle instead of a full circle. So for our big semicircle, the radius here, we can see the whole thing is 12, so half of that would be 6. For our little semicircle, I see 1, 2 for the radius. We can go ahead and do some algebra. 6 squared is 36, divided by 2 is 18 pi. Minus 2 squared is 4, divided by 2 is 2 pi. Since these are like terms because they both have pi, 18 minus 2 is 16 pi. And that is our final answer. This concludes our lesson. If you need to rewatch anything, you can always go back, rewatch. But if you're ready, go ahead and start the practice.